Assalamualaikum warahmatullahi wabarakatuh. So for inorganic chemistry subject, we are assigned to make a group assignment video. So for this video, we are going to introduce our coordination complexes. So we have picked an article that discussing about the preparation of the transition metal complexes and the characterization of the complexes using UV-Vis spectrophotometer. So let's get through it. The name of our complex is base 4 amino 5 pyridyl 4H 1,2,4 triazole 3 thiol copper 2. The formula of our complex is CuC7H7 and 5S2. So the geometry shape of our complex is square planar. So the structure of our complex will look like this. The coordination number of this complex is 4 and the type of this complex is neutral complex.
Assalamualaikum. My name is Ernie Nurshahira binti Abu Hanifah. So today I will continue a bit about the complex. The center metal of the complex is copper. The oxidation state of the center metal is +2. The name of the ligand is 4 amino 5 pyridyl 4H 1,2,4 triazole 3 thiol. Based on EAN rule, the complex is unstable. It is because the total electron is 35 electrons. Thus, it is not meshed with any of the noble gas. So, that's all for the introduction of the complex. Let's move to the next part for the explanation, bonding theory and electronic transition involved in the complex.
Assalamualaikum and hi everyone. My name is Noraina Shra binti Muhammad Asri. Today I'm going to explain about electronic transition in complex. Electronic transition in a complex are governed by selection rules. A selection rule is quantum mechanical rule that describes the types of quantum mechanical transition that are permitted. They reflect the restriction imposed on the state change for an atom or molecule during an electronic transition. Transitions not permitted by selection rules are said forbidden, which means that theoretically they must not occur, but in practice may occur with very low probabilities. The electronic transitions of transitions metal compounds can be categorized into three types: charge transfer, DD spin allows, and DD spin forbidden. Charge transfer bends occur when the excited electron moves from a metal central orbital to a ligand central orbital, or when the excited electron moves from a ligand central orbital to a metal central orbital. Charge transfer either ligand to metal or metal to ligands. These are often extremely intense and are generally found in the UV, but they may have a tail into the visible. Spin allowed and spin forbidden DD transitions find the excited electron moving from one d orbital to another d orbital. In the spin allowed transition of the spin quantum number, or more accurately, the spin angular momentum in the ground and excited states are the same, while in the spin forbidden transition, the spin state change during the excitation. The very broad absorption band is due to the excitation of the electron to various vibrationally excited states of the anti-bonding electronic state. In the case of cuprum, the bands appear at 280, 300, 312 and 451 nanometer respectively, and T2 and E2 respectively. Upon the absorption of light, electrons in the metal orbitals are excited to the ligand antibonding orbitals. However, the other complex were dimagnetic as expected for D10 ion, so that no DD transition can be expected in the visible regions. DD transition, this can occur in both UV and visible region, but since there are forbidden transition, have small intensities. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naim Muhammad Nasir. So we go through for the nature, bonding and magnetic properties of the complex basis of valence bond theory (VBT). Electron configuration of Cu2 plus is AR49. This is described that one unpaired electron in the metal ion leads to a net magnetic field. According to the journal Complex 4 bis 4 amino 5 pyridyl 4H124 triazole 4 copper 2 magnetic moment value is 0.7 Bohr magnetons, and this is believed that the copper 2 metal moiety exhibits square planar geometry. Magnetic measurements are widely used in studying transition metal complex. As the number of unpaired electron decrease, so the effect in magnetic field decrease. Triazole, which are the ligand in this complex, are 5-member heterocyclic compound with molecular formula C2H3N3 containing 3 nitrogen and 2 carbon atoms. Okay, because they involve both hard nitrogen and soft sulfur atom as thioamine group, so triazole are considered as a good coordinating ligand. The ligand have donor group that coordinate with wide range of metal ions. The tautomerism form could occur in triazole. This is why the structural isomer of chemical compound is readily interconvert. This reaction commonly results in the relocation of a proton. Okay, we go through to the electron configuration. The ligand determination as weak ligand as it cannot alter the configuration of the central metal ion. Huggins suggests that in square planar Cu C7H7 N5S2 Cu2 plus ion in sp2d hybridized. The hybridization of Cu here is sp2d. In this experiment, observation of Cu2 plus is not an oxidizing agent, and Cu2 plus convert to Cu2 plus conversion is not thermodynamically favorable. Hence that, for the electron is not excited, and configuration of Cu2 plus remain 3d9 in this complex. So the hybridization cannot be sp2. The experiment also showed that the complex is a square planar in shape. Hence, hybridization cannot be sp3. So, to explain the two experimental observations, hybridization of Cu is sp2d.